Welcome to 2.2, Newton's second law. Here we have a robot. The robot will push this cart on wheels. The robot pushes the cart on wheels with a force of 275 newtons. So what is the net force? Well, we have one object and one force. So the net force is just 275 newtons to the right. When the robot pushes the cart, what do you think will happen? Well, let's look at the speed here. So we're going to 275 newtons. Around there, close enough. As we can see, the speed just went up. Let's look at this again. Look at the speed over here. When we push on it, the speed just goes up faster, faster, and faster, and faster. So we see that, what do you think will happen to the cart? Well, it will accelerate. So big idea one, if we have a net force, there will always be acceleration. Next question, which box do you think will have more acceleration? It will speed up faster. Remember that if our speed goes from 0 to 10 to 20 to 30, that means the acceleration is 10. And if the speed goes from 0 to 5 to 10 to 15, that means the acceleration is 5. Acceleration is how fast we are speeding up or slowing down. Okay, well, let's look at both cases, A and B. So there's no friction here. Let's look at the first case, 500 newtons. Okay, look at the speed, it speeds up very quickly. 500 newtons. Next, let's look at B, which is 200 newtons. 200 newtons. It's speeding up, but not as quickly. Right? The speed is going up. Yeah. $500 newtons. It's going to speed up a lot faster. So which one has more acceleration? Well, A, 500 newtons. Why? Because more force, more net force. So what do we learn? As net force increases, the acceleration increases. Okay. So the big idea too, as net force increases, acceleration increases. So when F goes up, A goes up. Okay. All right. Finally, two scenarios. We are pushing two objects with the same force. A box, 50 kilograms, and a refrigerator. Which one will have more acceleration? Let's try the box first. So here's the box. Speeding up pretty quickly right now. It's going faster, 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 faster. Okay. Next, let's try the refrigerator. The refrigerator has more mass than the box, 300 newtons. Okay. It's speeding up, but not very quickly. As we can see with a bigger object, the acceleration is smaller. It's still going faster, it's still speeding up, but not so quickly. So which one will have more acceleration? Well, A. Why? Because A has less mass. So what did we learn? More mass, less acceleration. So big idea 3. as mass increases, acceleration decreases. Mass increases, acceleration decreases. Now, in fact, we have the three big ideas. If we have force, we have acceleration. Second big idea, more force, more acceleration. Final big idea, more mass, less acceleration. So more force, more acceleration, but more mass, less acceleration. In fact, we can put this together and say that A should be force divided by mass, because when F gets bigger on top, the fraction gets bigger. When M gets bigger on the bottom, the fraction gets smaller. So A should be F over M. More commonly, people usually do this. We multiply both sides by mass, and we get F equals ma. So really, one equation summarizes these three big ideas, and that's F equals ma. F is net force in newtons, m is mass in kilograms, a is acceleration in meters per second squared, usually. Okay. Let's look at some examples. Mr. Mike pushes his car, which has a mass of 2,000 kilograms. He pushes with a force of 200 newtons. What is the acceleration of his car? So if we draw a free body diagram, we don't know what direction, let's say this way. That's it. There's only one force. This one is not a force, it's a mass. So we know that F equals ma. Well, let's do this first. So m is 2,000. F is 200. We want to know acceleration. F equals ma. So 200 equals 2,000 times acceleration. Divide both sides by 2,000. And we get the acceleration is about 0.1 meters per second squared. So what does that mean? Well, the acceleration is small, which makes sense, we're pushing a car, but it's there. So that means that the car is still going to accelerate. Again, 0.1 meters per second squared means that if we start with no initial velocity, then after 1 second, we're going to be going at 0.1 meters per second squared. After 2 seconds, 0.2, 3 seconds, 0.3, and so forth. Okay. Let's look at two more examples. Example 2. Trang pushes a toy car with a force of 6 newtons to the right. Gene Valgrino pushes the toy car with a force of 4 newtons to the left. The mass is 2. There are no other forces on the car. Draw a force diagram. Here's a force diagram. The net force, they're going in opposite directions. So the net force should be 2 newtons to the right. So that's our force, net force. To find the acceleration, we know the mass is 2 kilograms. We want the acceleration. F equals ma. So 2 equals 2 times acceleration. Divide both sides by 2. And we get 1 equals a. So acceleration is equal to 1 meters per second squared to the right. Okay, that's it. final example. A person with a mass of 65 kilograms is in free fall. What is the net force on this person? Well, free fall on Earth, the acceleration is about 10 towards the Earth. In other words, mass is 65 kilograms, acceleration is about 10, and we want the force. Plug things in. And we multiply, we get 615 newtons. This is the net force on the person. In fact, this is the person's weight. Weight, the force of gravity, is what causes the person to fall with an acceleration of 10. Okay. So what did we learn? Well, we learned that if we have a force, we have acceleration. More force, more acceleration. More mass, less acceleration. This is summarized in Newton's second law, which says that acceleration is force divided by mass, or force equals mass times acceleration. Okay.